Apollo engineers used duct tape in space. Once, on a lunar rover fender. Then it failed in vacuum, lost its stick under solar exposure, and needed laminated map backup. That should have been the warning. Movies love the duct tape moment. Hero gets a suit puncture, slaps on a strip of tape, pressure holds, crisis over. Dramatic music swells, the crew exhales. It works because it's fast, visceral, and requires zero explanation. The audience understands duct tape. They've used it on cardboard boxes and car bumpers. If it holds those together, why not a spacesuit? Here's the boring detail. Spacesuits operate at 4.3 psi differential pressure. That's roughly 620 pounds per square foot trying to peel your patch off. And that's just the start. In vacuum, duct tape adhesive outgasses. The volatile compounds that make it sticky boil away in seconds. No air pressure means no atmospheric molecules to keep those compounds stable. The adhesive layer breaks down while you're still smoothing the edges. Temperature swings between sun exposure and shadow run from plus 250 degrees Fahrenheit to minus 250 degrees Fahrenheit. The tape contracts, cracks, and peels at the molecular level. Lunar dust, the stuff that wrecked Apollo's fender repair, is electrostatically charged, sharp as glass shards, and embeds itself into every surface it touches. It prevents adhesion better than any release agent. Now overlay the human timeline. You lose consciousness in 9 to 12 seconds once deoxygenated blood reaches your brain. The suit's emergency oxygen system is designed to handle specific puncture diameters, small holes, not gashes, and gives you roughly 20 minutes under ideal conditions to reach safety. If the breach exceeds that diameter, the high-pressure emergency tank can't maintain suit pressure no matter how much oxygen it dumps in. Your patch isn't sealing a static surface. It's trying to hold against explosive decompression while you're hypoxic, shaking, and operating in a bulky pressurized glove that reduces dexterity to roughly mittens at a piano levels. Sounds heroic. The math disagrees. Movies skip the part where you have to brush off lunar dust in a vacuum while your suit pressure drops. They don't show the crew members' vision narrowing as oxygen starvation kicks in before the patch even adheres. They definitely don't mention that even hand pressure over the leak, an option NASA actually lists as more effective than tape in a desperate scenario, buys you more time than fumbling with adhesive that's already outgassing. Here's the alternate cut. Modern spacesuits carry pre-staged emergency oxygen reserves and are designed with leak tolerance baked in. The Apollo suits had auxiliary oxygen tanks on each suit, plus an interconnect hose system so one crew member's tank could feed another's if a puncture occurred. Ugly, redundant, and slower than a heroic tape slap. Also, it actually worked. Current shuttle suits give you 20 minutes of high-flow emergency oxygen, specifically calculated for worst-case return time to a pressurized environment. The strategy isn't patch the suit, it's get indoors, then repair, with internal pressure helping hold the patch from inside using specialized adhesives designed for vacuum bonding. And here's where it gets worse. If you're on the ISS and the station itself depressurizes, the crew doesn't patch anything. They execute a divide and conquer protocol, close hatches between modules, monitor pressure sensors, isolate the leaking segment, and if reserve time drops below 10 minutes, abandon that section entirely and retreat to the Soyuz escape vehicles. No one stays to fight the breach. The procedure assumes the breach wins. The goal is controlled retreat, not heroic repair. The cinematic version has the crew member slapping tape on a torn glove, hearing the hiss stop and continuing the EVA. 30 seconds later, the tape peels back in a ribbon, the suit pressure alarm screams, and they've got 9 seconds of consciousness left to cover 50 meters back to the airlock. They don't make it. The emergency oxygen system was designed for a pinhole, not a gash. The tape never had a chance. The realistic version is slower and infinitely less dramatic. The puncture happens. The suit alarm goes off. High-pressure emergency oxygen kicks in automatically. The crew member stops all work, signals their partner, and makes a controlled return to the airlock while their suit fights to maintain minimum pressure. Once inside, they use internal vacuum-rated adhesive and bomb the patch from inside the suit where pressure differential works in their favor. They're alive, the suit's repairable, and no one tried to be a hero with office supplies. Which other sci-fi survival move do you want stress-tested next? Explosive decompression and grabbing something heavy? Sealing a hull breach with a metal plate and some sparks? Drop it in the comments. Another beloved space strategy is going on the chopping block.